Welcome to part 3 of the single family load calculation videos. This one's going to be a review of what I went over in the first video and in the second video. And then I also had the optional method video, so I'm also going to tie in that. And what I'm going to be doing here is a summary of everything. But not only is it going to be a summary, but it's also going to double as a page layout. So I'm going to teach you how to lay out the page in order to do these load calculations. And then at the same time, it's going to teach you everything summarized up. The reason why I'm doing a video for this is because if you saw my part 2 video, I showed you the 25% of the largest motor rule. There was already so many things that I taught in the first video that if I put everything in one video, I was afraid that it might be a little too much, or that it's easy to forget a step along the way, and that the 25% of the largest motor is one of the easiest things in my opinion to forget. So I decided to give it a little more attention on its own and actually make a whole video about that. And then that also doubled as me showing you how to find the minimum size over current protection device and why you size up normally and how you know when to size up and when to not size up. So make sure to watch. That was the part 2 of the residential load calculation videos. And then I also show you how to find out the size of wire. You might think you just go to table 310.16, but I show you that normally you're going to be using table 310.12. It's all explained in that video. It's a good video. And since that was part 2, that was still the single family dwelling of the residential load calculations. And that's where I was showing you that 25% of the largest motor. And in that, I mentioned that's only in the standard method. So that's also what I'm going to highlight in this video. You'll see when I show you the page layout, along with the difference between the summary of each ones, we're going to see that you do 25% of the largest motor for single family dwellings with the standard method, but for the optional method, you don't do 25% of the largest motor. That is just something you entirely do not do in the optional method. It's only in the standard method. And along with that, in the standard method, when you go to your duplexes and your multifamily, we're talking about dwellings here, then you're only going to do that 25% of the largest motor one time, no matter how many units you have. Again, that's explained in that part 2 video, and I'm also going to show you in these upcoming videos now that 25% of the largest motor. I'm going to have a duplex video and a multifamily video, so look out for those. Those are the videos right after this. I'm going to have it for the standard method and the optional method, and I'm actually going to start off the videos like how I'm going to show you in this video the page layout, which also goes over the directions and a summary of how to do that specific load calculation. So you'll see in those next upcoming videos, it's going to start like that. So if you're filling out your sheet of paper, you're going to be able to fill it out accordingly, or at least practice that. And then I'll get into me actually doing an example. Okay, and since I already have the examples in the other videos, this video is purely going to be a summary of single family load calculations and showing you the difference between the standard method and the optional method, which is going to help you a lot when you also go into duplexes and multifamily. Okay, we're looking at the single family, the standard method. Of course, we're going to get the square footage of the house. What we do is we always times that by 3, and that is volt amps. In other words, we're getting 3 volt amps per square foot. This is why we do that. It tells us this in the code book. We get ourselves a number. I'm just going to call it N to not complicate anything. We're not doing an actual problem here. But at all times, we're going to then add a 4,500 if there are no exceptions. I'm going to get into that in a second. So basically, at all times, we're going to add a 4,500 number. This 4,500 comes from 2 small appliance branch circuits and 1 laundry circuit. They're each at 1,500 volt amps. So if you take 1,500 times these 3 circuits, you get 4,500. Be sure to check out Article 220.52b, which will then take you to Article 210.11c2. From here, you can then go to Article 210.52f. They all lead to each other. And you will see that this article contains 2 exemptions that will allow you to not include the laundry circuit of the load calculation if there is that exemption when someone is asking you about that certain load calculation. So make sure you are aware of that and you highlight that in your book. That is something important to know. So just a simple recap, we get a square footage of the house, we multiply it by 3 volt amps, we get that number, and we add another 4,500 it's going to be volt amps to that. After we get that total number, then we're going to have our demand factors, which are kind of complicated. Those are explained in the videos on the individual standard and optional method. So there's the demand factors here for the standard method, and this is on what's called the general lighting load portion of the calculation. Okay, so if you aren't sure about the demand factors, be sure to check out the part 1 of the load calculation video. Then also check out my upcoming video, which is going to be load calculation magic number, and that'll show you that when you have anything that's over 120,000 volt amps here, when you're doing those demand factors, there's a magic number that you're going to get from your first 2 portions every single time. And if you know that number, then you know you just have to add that number by the remainder at 25%. I'm explaining it pretty simple here, and you'll see it is pretty simple. So it's good to know that number. So when you're doing it and you are solving it for yourself, you see that number, you know you're doing everything correctly. And if you don't see that number, then you know you messed something up. Okay, and when I actually fill this out, like on a paper, I like to separate each one of the big sections with a line. So here's my first line, and that's going to isolate the general lighting load portion. Okay, the next portion we have are appliances. These are going to be anything that are fixed in place or have their own dedicated circuit. In other words, home run to that appliance. So to elaborate on that, that's not going to be anything on the countertop. If you have anything that you plug in after purchasing the home, a toaster oven, a toaster, a blender, that's not going to be an actual appliance in a load calculation, because those are countertop appliances that are not fixed in place with the actual home, and there's no dedicated circuit going to them. And with all the stuff that I teach, that first video of the load calculation video teaches you everything from the book. So I actually explain where to find all that in the book, which just helps you actually be able to read it on your own, remember it, and then if you need to, find it on your own as well and know where to find it, which is the most important thing when using the code book, is know where to find things. Okay, we're going to look at article 220.53, and we'll see that when we have 4 or more appliances, then they're going to be calculated at 75%. And this is if these appliances are at 500 watts nameplate or a quarter horsepower, and of course, or greater. This means that if you have less than 500 watt or quarter horsepower appliances, that you do not have the demand factor of 75%. So that's where the difference is. You might have some appliances that are a 6th horsepower or 450 watts. You're going to rate those at 100% regardless of any situation, because those are not going to be affected by the 75% demand factor. Okay, so here I am drawing my next line, separating appliances. Now I normally have a longer sheet of paper, in other words, in the portrait dimensions instead of the landscape dimensions, so I would normally draw this vertically. But in this case, I don't have that much room, so I'm going to draw this horizontally, and that is the H, which I normally draw very close to the A, heat and AC, because you pick the bigger one. And then R and D, I normally separate those a little more, because you pick either heat or AC, whichever one's bigger. Let's say your heat is bigger, then you're going to disregard your AC. Then you're going to look at your range. You're going to see if you have your nameplate, and then you're going to go to table 220.55. You're going to see what your appliance is rated. You're going to find the column that corresponds with that, and then you're going to find the number of those appliances at that rating. Of course, if they're all at different ratings, they're all going to be individual. So if you have 2 appliances at the same rating, let's say they're 8 kilowatt, you're going to use column B, and since you have 2 appliances, you're going to get 65% when you line those both up. I'm not writing this down because I'm just sharing that with you if you want to know how to use that. If you don't know, of course, column C is not percentage, that is actually a load. So they're telling you if you have 1 appliance and you're using column C, then you just have 8 kilowatts. And when doing some practice questions, I saw this pop up, and I never saw this before, so I don't know how completely legitimate this is. But in the practice question, they mentioned a range that didn't have a nameplate, and what they showed you to do was for the single family just to go to column C. So you go to column C and you see 8 kilowatts. And then they also showed if there was no nameplate for duplexes, and there's a difference if it was the standard method or optional method. It was kind of weird. So I'll actually show you that in the individual video. So look out for that when you're watching the standard method duplex and the optional method duplex video. And that'll be when you see a range with no nameplate. What are you going to do? Okay, so after we figured out the demand factor or the load that we're going to have for the range, then we're going to go to dryer, and their dryer is going to be at 5,000 watts minimum, or the nameplate, whichever one is greater. That's article 220.54. And then you do have table 220.54, which is your demand factors for your dryers. But as you'll see, 1 through 4 dryers is at 100%. But do not get too full of yourself and think that you just have everything memorized. Just keep your book open. It's all in a few pages. And when you're on dryers, just look at the book. Just double check that, okay, yeah, 1 through 4, 100%, so you don't do anything. And then we have one more step at the end of it. We have the 25% of the largest motor. I normally just do 25% LM. Good enough. LM stands for largest motor. We get all those individual numbers and we add them all together. I'm going to call that the total as T. After getting the total, which are volt amps, you're going to divide that by 240 volts, and that's going to give you your amps. Okay, after getting your amps, you're not done yet, because you might have a number that's not exact, or in other words, it might not be a standard ampere rating. To find that standard ampere rating, you're going to go to table 240.6a, and you're going to see that as the standard ampere rating. This includes the inverse time breakers and fuses. Here in the table, you're going to see a bunch of different numbers. And basically what people normally know is that whatever number you see, let's say you have 215 amps, you're going to see if that falls on one of the numbers there. You see 200, you see 225. So since it falls in the middle of two numbers, you're just going to round up to the bigger one. And you normally do this, but it's good to know Article 240.4b, which tells you that basically if it's 800 amperes or less, you're going to do that. And in other words, you're going to round up to the next bigger size of breaker, unless that next bigger size is 800 amps or bigger than that. Now I'm supposed to just be summarizing this. This is extra, so I'm just going to mention this stuff on the first one here. And the last thing I'm going to mention is that then when you need to know your wire size for your actual service, you're going to go to table 310.12, and you're going to see services between 100 and 400 ampere. Okay, so that's the summary of the single family standard method. Take a good look at it if you need to. If my head was in the way of it or anything, then now you have a good chance to really take it in. Okay, now the optional method, still in single family dwellings, we're going to first do square foot times 3 volt amps just like before, and then we're going to add that 4,500 to that just like before. The difference is this time we're done. We don't have the demand factors. Okay, that is the general lighting load portion. So again, I'll just write GLL and circle it there. Next, we have appliances at 100%. There's no demand factors. There's nothing telling us if we have this many, we got to do anything. All the appliances that we have at nameplate value, we're going to calculate at 100% value. Okay, so that's it for that. Okay, and again, we have the HARD. I normally do that vertically, but for space here, I'm going to do it horizontally here. Okay, so I'm going to do the same thing, HA together, and then RD separated. You can check out 220.82c, where you have heating and air conditioning loads under the Part 4 optional method section of the load calculations. You're going to see that you need to check your heat for some of your demand factors. If they mention supplemental electric heating, then you see demand factors for that. And then if you also see separately controlled units, there's demand factors, whether you have less than 4 or more than 4. So basically check for demand factors on your heat. You'll see with AC there aren't really demand factors. And then of course you pick the bigger of the two. So again, let's say we had bigger heat than AC, then we're going to pick the heat and disregard the AC. We have the range, this is going to be at 100%, and then we have the dryer, which is also going to be at 100%. So both these at the value that you have are at 100%. Again, this next part's only for single family optional method. So it's only using the optional method, only for single family. And again, to duplex and multifamily with the optional method, you don't do this. And what we're doing is we're going to add everything except heat and AC. Okay, so we're going to leave heat and AC by itself, but we're going to add the appliances and the general lighting load. Then we have a demand factor, and that is 220.82b. We see the first 10 kilovolt amps is at 100%, and then the remainder is at 40%, and you, of course, add those two together. So here I am drawing the next line. After doing that demand factor, then you're going to add back the bigger of the heat or the AC. So of course, let's say we did the heat and not the AC. We're just going to pick the heat and we're going to add that back. Remember, there could be the demand factors for the heat, so make sure to check that. Whatever number we get for heat or AC at that portion, we're adding that back now. Okay, so pretty simple, but just to go over it one more time for the optional method, I just noticed I wrote a plus there. Okay, but you get the point. So for the optional method, general lighting load, we have the square foot times 3 volt amps. We get that number, we add the 4,500 volt amps. Of course, it's for the 2 small appliance branch circuits and the 1 laundry circuit. Then we get to the next section, appliances. These are just at 100% of the nameplate value. Then we get to the next section, we have the heat and the AC. We pick the bigger of the two. We check for those demand factors with the heating. And then we get the range and the dryer. Those are just at 100%. In other words, we don't use those tables to find any demand factors. We just get the number we're told and we add that to the rest of our calculations. The next step is just to add everything except for the heat and the AC. This is only for single family using the optional method. Then you have a demand factor for what you just added together. After doing that demand factor, you're adding back the heat or the AC, whichever one is bigger. And now you're done with the optional method for single family dwellings. Okay, so now that we completed that, I'm going to show you side by side the optional and standard method for the single family dwellings, and we're going to compare them. Okay, so the first thing is we see in each section of the standard method, we have some demand factors. When we're doing the general lighting load portion, we have those demand factors. When we're dealing with appliances, if we have 4 or more, they're at 75% if they're 500 watts or a quarter horsepower or greater. And then when we get to the heat and AC, we're basically just picking the bigger one there. But for the range and the dryer, we have those tables where we have demand factors. So there's a lot more demand factors to pay attention to in the standard method. And then to add on that, the standard method, we have the 25% largest motor. And you can't forget about that. Of course, if you want your answer to be accurate. Then we look at the optional method, we see the general lighting load portion does not have any demand factors. We still do the square foot times 3 volt amps, and we still do the 4,500 for the 2 small appliance branch circuits and 1 laundry circuit, but there's no demand factors. Then we go on to the second portion of the optional method, and we see the appliances are at 100%. So again, there's no demand factors. The thing to pay attention to is when we move on to heating and AC, you need to check those demand factors for the heating. It'll be pretty obvious if they mention there's a separately derived system, or if there are multiple units, or if they say there's multiple heads. In other words, they're using a mini split system. So they might use a little bit of slang there, but if you know your stuff, then you'll know what they mean. Then we get onto the range and the dryer, and those are both at 100%. So we get the number that we're told, and we get 100% of that. And then once we finish that, the optional method for the single family is pretty specific because it has its own demand factors and it has its own way of doing the demand factor. So again, like I just went over, we're going to add everything together except the heat and the AC. And then after we do our demand factor, which is the first 10 kilovolt amps at 100% and the remainder at 40%, after doing the demand factor, then we're going to add back the heat or the AC, whichever one is bigger, and that will be our total number for the optional method. The optional method is kind of peculiar for the single family, but for the duplex and the multifamily, we'll see it's a little more straightforward, except for the fact that for duplexes, we're counting them as 3 units. So make sure to check out those videos because especially for duplex, using the optional method, you have to know that you're going to count it as 3 units and use the multifamily table for the optional method. So that's it for this video. Again, I'm not actually solving anything and doing any calculations. I'm just doing a summary of the calculations. And from now on, I'm going to begin the videos like this, basically summarizing what we're going to do in the video, at the same time showing you a page layout of how to fill out your page as you're filling it out with me. And then I'm going to get into the calculation portion of it, actually having an example and then solving it. If you're confused about anything, if you have any questions or even comments, feel free to leave a comment down below. Make sure you subscribe so you see when I post videos. And if you got something out of this video and you liked it, give it a thumbs up and share it on social media with some of your friends. Until next time, have a good one, take care, and goodbye.